Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about a Leaving Cert exam question from 2015 paper 1, and that question is question 7. In this question we're told that the descent of a plane as it begins to land can be described by the function f of x, and we're told that the airport is the point O, which is the origin, which is 0, 0. And in the first part of this question we're asked to prove that d is equal to 0. So you'll see that I've already done it out here. If this is my function f of x, and I know that the point 0, 0 is on this function, that means that I can just sub in 0 for my x and 0 for my y and work out what my d is. So if everywhere there was a y, I sub in 0, everywhere there was an x, I sub in 0, and I just end up with d is equal to 0. Because the question told me to show, I just tick it, I do a little conclusion at the end, so I tick it and say that it's true. Okay, so for the second part of this question, you'll notice it's almost identical to A part 1. In this case, we're told that the coordinate minus 5, 0.15 is on this function. So that just means if I sub in, instead of f of x, I can sub in 0.15. Instead of x, I can sub in minus 5, and that should allow me to work out my c. So when we work our way through this question, we end up with c is equal to 0. And once again, because it asked me to verify this or to show this, I put a tick beside it and say that it's true. Okay, now in the next part of the question, we're asked to find the derivative of f of x when x equals minus 4. So notice now my c of x and my c times x and my d are gone because I know c is 0 and I know d is 0. So my f of x has now just got two terms in it. So to find the derivative, so for the first term I bring the power in front. So 3 by 0.0024 gives me 0.0072. Then I decrease the power of x by 1, so it becomes x squared. For this one, I bring the power in front, so 2 by 0.018 is 0.036, and I decrease the power of x by 1, so it just becomes x to the power of 1. So I know that's my first derivative. And I was asked to get the first derivative when x equals minus 4. So that just means I'm subbing in minus 4 instead of my x. I work it out, and my final answer is minus 0.0288. So the first few parts of this question were quite nice, and now we're going to move into kind of the more theory-heavy part of the question. Okay, so for the next part of the question, the maths itself is quite straightforward here, but I want you to make sure you understand what we're doing because this is a bit theory-heavy. We're asked to use our answer from B part 1, which is this, in order to find the angle at which the plane is descending when it is 4 kilometers from touchdown. So I've drawn a rough sketch of our diagram here. 4 kilometers from touchdown, it's where x is minus 4. So it's roughly somewhere around here. I want to find the angle at which it is descending. In other words, I want to find the angle with which the function makes with the horizontal at this point. So I want to find the angle that the function is making with the horizontal when x is minus 4. So the first thing I should do is draw a horizontal line. Okay, so I'm just drawing a horizontal line here. And I want to find the angle with which the plane is descending. So the angle is the one between the function and the horizontal line. So if I just draw a little arrow in here, that's the angle I'm looking for. I'm looking for this little angle here. Now I want you to recognize that when you get your first derivative, you're getting the slope. The slope is the rise over the run. Okay, so slope is rise over run. If you imagine this in a big, if I blow this up a little bit, imagine this is my theta here. My slope would be the rise over the run. I know that the slope of the function when x is minus 4 is minus 0.0288. So I know the slope of the function at this point is minus 0.0288. And the slope is the rise over the run. But I want you to recognize that the rise over the run, if this was a right angle triangle, that's the opposite over the adjacent. And the opposite over the adjacent is the tan of the angle. So when you get your first derivative, not only are you getting the slope, you're also getting tan of the angle that the function makes with the horizontal line. So basically you're getting the opposite over the adjacent. If I know that the first derivative, if I know the derivative when x is minus 4 is minus 0.0288, then I know that the tan of the angle, or the tan of the angle the function makes with the horizontal line is minus 0.0288. So when you get your first derivative, you're also getting the tan of the angle. It's the same concept as when you're getting your slope, except it's the tan of the angle with which the function makes with the horizontal line. So when you recognize this, it's a very straightforward question. You just think of your unit circle. So if you think of your unit circle here, clearly this angle is between 0 and 90 degrees. So it's in the first quadrant. And in the first quadrant, sine, cos, and tan are all positive, which means that I want to take the positive value here. So I want to get the tan of theta when it's equal to 0.0288. So the easiest way to work this out is to just get tan inverse of 0.0288. So if I just get tan inverse 0.0288, again, make sure your calculator is in degrees for this one. The answer here works out as 1.649. And it asked me to leave my answer to the nearest degree, which means that I know the angle is descending at 2 degrees. To the nearest degree, this would be 2 degrees. It's 2 degrees to the horizontal line. Okay, so again, I hope that makes sense. The key to this question is just that when you get the derivative, you're not only getting the slope, but you're also getting the tan of the angle. Okay, so for part C of this question, we're asked to show that there's a point of inflection exists at the coordinate minus 2.5, 0.075. Now straight away you should recognize that a point of inflection, at a point of inflection, the second derivative is equal to 0. So they're telling me, let your second derivative equal to 0 and find the coordinate. So we know that we have here our f of x, and in the previous parts of the question we've been working with f dash x, our first derivative. So to get our second derivative, we need to differentiate our first derivative. So if our first derivative is 0.0072x squared, you bring the power in front, 2 by 0072 is 0.0144, and power of x decreases by 1, so that's x to the power of 1. My second term here in my first derivative is 0.036 x to the power of 1, so you bring the power in front and you decrease the power of x by 1. So it's just 0.036. So this is my second derivative. And now I need to find the point of inflection. I know a point of inflection exists when the second derivative is equal to 0. So I let my second derivative equal to 0, and now all of a sudden I've got one equation and one variable, so I'll be able to find the value of my x. So all I did on the next line was I subtracted minus 0.036 from both sides. So, and now in order to isolate my x from this line, just divide both sides by 0.0144, and I end up with x is equal to minus 2.5. So I know that a point of inflection exists when x is minus 2.5. However, that's not enough, and a lot of people's inclination might be to stop there. They asked me to prove that that the point of inflection is minus 2.5, 0.075. So I also need to prove that when x is minus 2.5, y is 0.075. So in order to do that, what we need to do is sub back into our original function. So in the next line, I've subbed back into my original function. And I want to know what is the value of y when x is minus 2.5. So I just rewrote my f of x, except everywhere there was an x, we sub in minus 2.5. And this one simplifies down, and we end up with y is equal to 0.075. But again, we were asked to show this, so we've just verified something, so make sure you put a little conclusion in. So the way I've concluded this one is I just said there's a point of inflection at minus 2.5, 0.075. So as you can see, I've worked my way through this question. Now don't be intimidated, it looks very complicated, but it's basic enough, it's just there's a lot of terms involved. So all I've done here is, this is my original function, and I have to sub in the coordinate minus x minus 5, minus y plus 0.15, and prove that this is a point on the line. So all I've done in the next line is everywhere there was an x, I've subbed in this. Everywhere there was a y, I've subbed in minus y plus 0.15. On the next line, what I've done is I got my minus x minus 5 and I've cubed it. So I've multiplied it by itself 3 times and I got this. I got minus x minus 5 and I multiplied it by itself twice and I got this. On the following line now, the easiest thing to do is to multiply 0.0024 by these 4 terms and multiply 0.018 by these 3 terms. The next line I probably didn't need, but it's easier for me to explain it if I have it like this. All I've done on the next line is I've got only 1x cubed, but I have 2x squareds. So I've grouped my x squareds together. I've grouped my x's together, and I've grouped my numbers together. You'll notice here that plus 0.18x and minus 0.18x will cancel each other out. And when we group all our like terms, we're left with minus y plus 0.15 equals minus 0.0024x cubed minus 0.018x squared plus 0.15. So you'll notice that my 0.15s on each side will cancel each other out. And I'm left with exactly what I have at the top, except with different signs. So all I need to do is change the signs of everything, and I'm left with what I have at the top. Now this question seems to end quite abruptly, so you'll see I've done quite a thorough conclusion. So once you get to this line, you've proven it. So that's all the maths that we have to do. Because the question said at the start that the coordinate x, y is on the curve. So that means I know that this is true. So I've said here that this is true, put a tick beside it, and say this is true as x, y is a point on the curve. And my final conclusion then, I have 3 dots in the shape of a triangle, which means therefore, this coordinate is a point on the curve. Okay, so for the last part of this question, we're asked to go from the coordinate we used in D part 1 to the point of inflection and the same distance again. I need to find the image of this point under symmetry in the point of inflection. So whatever distance I traveled to get from this coordinate to this coordinate, I want to travel the exact same distance again in order to get to the image. So I need to work out what did I do to get from here to here and then do the same thing again. So we'll have to split this up between our x values and our y values. So let's just worry about our x's for the moment. What did I do to minus 5 in order to get to minus 2.5? Well, to go from minus 5 to minus 2.5, we must have added 2.5. Minus 5 plus 2.5 gives me minus 2.5. And then I also have to worry about my x's, my variable here. What did I do to minus x in order to get to 0x? Well, if I have minus x, I must have added x, because minus x plus x will give me 0x. So what I did to get from minus x minus 5 to minus 2.5 was I added x and I added 2.5. Which means I'm going to do the exact same thing to get from here to here. So what I want to do is I want to add x and I want to add 2.5. So clearly here I've got 0 x's. So if I have 0x and I add x, then I'm going to end up with x. And if I have minus 2.5 and I add 2.5, I'm going to be left with 0. So actually the value here of my x value is just x. Now let's do the same thing with the y. So let's do the same thing with these values. If I have minus y plus 0.15, what did I do to this in order to get to here? Well, clearly I have minus y here and I have 0y here, which means I must have added a y, because minus y plus y gives me 0. And if I have 0.15 here and I have 0.075 here, I must have subtracted 0.075, because 0.15 minus 0.075 will give me plus 0.075. So that's what I did to get from here to my point of inflection, and I want to go the same distance again, which means that I want to add y and subtract 0.075. So on the point of inflection, I've got 0y, and if I add y, I'm left with just y. For my numbers, I've got 0.075, and I'm going to subtract 0.075, which means my numbers cancel out. So the image of this coordinate under the point of inflection is just the coordinate x, y. So the numbers look very tricky, but when you got that one right, once you got a value like this, I think that would have been a very nice thing to get in your Leaving Cert, because you would have had a fairly good idea that you must be right when you get a value as neat as that. So again, I hope this video made sense. I think a lot of this question was quite nice, except for the fact that the figures were just incredibly difficult. The figures were just really awkward, but the maths itself was quite nice. So if there's anything you're unclear on in this one, just let me know in class during the week or send me an email and I'll try and explain it differently.